First, you must realize that you have no idea before you can know the idea. We scan across all the frequencies if we want to learn anything new. Let us begin.
What has physics done for me lately?
Furthermore, the equation E is equal mc squared.
We have now acquired a fateful power to alter and to destroy nature.
That's like when you're in physics and you go to Dreamworld saying, oh, this is a physics excursion.
Science. What is it all about?
The whole of human history all falls in the dust of one stroke of the nail file. You can't really get to grips with evolution unless you realise what an enormous amount of time.
Our own planet is only a tiny part of the vast cosmic tapestry, a starry fabric of worlds yet untold.
You're tuned into what can only be described as the best radio station on this blue dot. We call Earth. It is, of course, 4ZZZ, your community broadcaster. Be it on your convenient conventional wireless radio by tuning into the classic frequency of 102.1 FM devices, such as digital devices such as DAB or smart speaker, listening via the Community Radio Plus app, or streaming us live from our sensational website at 4ZZZ.org.au. And of course, you can always listen back to our show. Yeah, just listen to our show on the on-demand feature, also found on that URL. We also have a weekly podcast of the show for your listening pleasure, curated by Gabe. That'd be funny, wouldn't it? What a nightly show, Gabe.
Just giving Gabe work now.
No idea.
Randomly.
After hours, baby.
Curated by Toby, a condensed version of the show without the music, which my mum prefers. Just search for our show name, which is, of course, No Idea, spelt with a K, your weekly dose of science, interlaced with a nearly all, Backstreet Boys playlist this week.
Oh, don't spoil
Backstreet
it.
Boys.
Yeah. And joining me for this episode are four of my favourite science influencers. Good morning, Gabriel.
Good morning.
I swapped that around, didn't I? Good morning,
You did.
Peter.
Hello, Max.
We're not meant to say good morning.
No, we're not.
Hello, Issy.
Good evening, Max. There you go. Neutralise it all.
Hit them all.
Use everybody.
Neutralise the
Good
target.
evening,
It's
good
show
night.
number 686. Do you know there was a paper in 2018 published in PLOS One that predicted how many marine species would have their habitat shift in response to warming waters in the North Atlantic? And it was 686 species.
It's less of a fun fact and more of a depressing fact, but sure.
686. Yes, but Max, I do have Backstreet Boys coming up, which is a bit more of a fun fact because some neuroscientists have done a study on monkeys, which includes why the Backstreet Boy has included using the Backstreet Boys to try and learn about the evolution of music and keeping a beat.
Oh, great. So, the question is, when will monkeys create the Backstreet Boys, I imagine? Which is a great question. It's
How
something
many
we need to
monkeys will
ask.
it take before, if they were all randomly making music before it creates the Backstreet Boys? Sure. Let's
Great.
do that one.
Fantastic.
What do you got, Max?
I'm talking about ethical lab research, with animals, so forth.
Nice.
Great.
Is he?
Good to keep in ethics.
You'll find out in the second hour when I write it.
No
I
rush with that.
love a teaser for what's going on. I've got two great marine stories today. One of them is how we are able to get 2 sharks for the price of 1. Very exciting.
I remember when we first met.
Yeah, sorry.
What are you kicking us off with?
What was that? Interrupting women. Go on, Peter.
Yeah.
That's it. Tale of the Tuna. You'll find out later. I'm not telling you any more about the tuna till later.
Who's up, Peter?
Oh, right. Okay, so Gabe, you're kind of our resident animal dude, right? I think.
Sure.
Do we all agree that Gabe's the resident animal dude?
Yep.
I don't have any claim on anything in the ocean or cane toads, which are
That's
most
true.
of the animals.
I've taken most of the animals off you. Izzy's taken a key one. So, here's the question. What are some things that animals put a lot of energy into?
Staying alive.
Breeding and feeding.
I was going to
Breeding
say
and
the
feeding.
two.
The big two.
The big two.
Reproduction. It's kind of the driving force of most organisms on the planet. A lot of what you're designed to do is to reproduce, go out, multiply.
Come to think of it, why don't we all go forth and multiply?
That was me quoting Happy Feet, by the way, which I think is a quote of something else, but I'm quoting Happy Feet, and that's important to put that down. So bodies do a lot of crazy impressive things, but none so much as reproduction. Not the initial act that's really impressive, but the creation of life in all forms is incredibly impressive. I would argue, personally, that being viviparous or giving birth to live young, like we do, is the most impressive. Shout out pregnant people, you're going through it, major respect. But any kind of life creation is hard. And you kind of expect it to be, because from an evolutionary perspective, it makes a lot of sense to put a lot of your resources into reproduction. It's kind of your number one thing to be doing over your life, theoretically, as an organism. Which is what makes this new finding so weird, because epaulette sharks just don't. Now, if you've never heard of an epaulette shark, these are gorgeous.
What do you mean don't?
I'll get to how they don't, but they just don't.
So
They
take
don't.
this concept and throw it away.
Throw it away. Take all of that we've just thought about, put that out the window. Now we're talking about epaulette sharks. They are stunning little sharks, if you haven't seen them before. They're also known as walking sharks. They are small little guys. They live on the bottom of these warm, shallow waters in the Great Barrier Reef. They only live in the Great Barrier Reef. They exist nowhere else on Earth. They are beige with black spots all across their body. And they're called walking sharks because they balance themselves on their little pectoral fins, which means like essentially their arms, I guess, is what you would think of them as. And they sort of balance themselves up on it, and then they'll walk. They'll use those to push themselves around the seafloor, hence why they're called walking sharks. They are so cute. I can't tell you how cute these sharks are. They are, like, if you ever get the chance to see them, go see an epaulette shark. But another cool thing about epaulette sharks is that they are oviparous, meaning that they lay eggs. And that's important for you to know. So some researchers from James Cook University, QS a ranking, please.
James Cook, 250.
Yeah, it's up there. 187.
172.
It's 440.
Oh.
It's a little further up there, but that's okay.
Yeah.
They realised that no one had actually measured what's known as the metabolic cost of egg laying in sharks. So how much energy is it costing you as an organism to lay an egg? You'd expect it would be high. And the cool thing about epaulette sharks and why they looked at them was because they're really fast. They produce 2 to 3 eggs every 2 weeks between September and December. That's a lot of eggs. Like, fish do reproduce, but sharks generally reproduce less, so that was mind-blowing to me to know that they reproduce that much. But it's useful for these researchers because if it's quick, it means they can do more research on it. They can see the changes very quickly. So they had 5 female sharks before, during, and after egg case formation. The sharks were kept in large, temperature-controlled tanks, which allowed the researchers to carefully measure changes in energy use. So they mainly looked at their oxygen uptake rates, which is how you sort of look at metabolic rates, because the more oxygen you burn, the more energy you're using. Pretty simple, right?
Uh-huh.
And they saw nothing. Like, nothing changed. They also looked at their blood and their hormones, and nothing, like, they just stayed the same the whole reproductive cycle.
Nice.
And it's just crazy because the expectation was that the sharks were producing this complex egg, making life, that you would use a lot more energy, but no, they stayed the same. They've essentially changed their physiology to optimize their energy use. So aside from just being physically impressive, why is this so important? Well, when things get tough and resources are to go is usually reproduction. Survive, then thrive sort of thing, you know? Like, just stay there until you can reproduce again later. But this implies that even under environmental stress, epaulette sharks may be able to just continue reproducing, which is very exciting because obviously the reef is under a lot of extreme environmental stress, so it's something that could potentially affect a lot of things, but maybe not epaulette sharks. Of course, I think it's obvious that I need to say here, this is not a full steam ahead, let's test it out sort of a situation. Just be grateful that there's an idea that they might be okay, because they're very cute and fun. But it's super cool because you'd never expect creating life to cost you nothing. Certainly doesn't for us. Cost you a lot. Pretty jealous, to be honest. That sounds great.
So they put these 26 babies into these MRI machines, and they were very proud of being able to get them one at a time.
They're all strapped in a circle around the machine.
Sorry.
That's right.
You shouldn't have mentioned babies in an MRI machine. Just told us that they measured their brains. It's just so funny.
Bring it on.
That babies in an MRI machine sting has stuck with us since about this time last year when I first ran that story. The paper, do you remember the paper that it was about?
No.
Here's the real test.
To be honest, hang on. No, give me a second. It was something about babies in MRI.
Make you laugh.
It made me laugh. What was it? They were like thinking about stimuli. They were trying to measure their brains about like stimuli from. I'm trying to remember what the stimuli was. I don't know.
They put put babies into MRI machines. A few dozen of them individually on their own were placed into MRI machines, and they were showing them pictures to test their memory. Clearly, we need to do some MRI machine tests on the No Idea host audience. There were more activities in areas of the brain associated with memory, like the hippocampus, when the babies were shown images they'd seen before, which was an indication that we are able to start forming memories at quite a young age, younger than they'd thought previously. They tested a wide range from a few months to about 12 months, and they found that all of those babies, even the youngest ones of a few months of age, were showing memory-related brain activity, which is similar to what you were talking about with the epaulet sharks. They're measuring oxygen. The fMRI machines that they're using here also are measuring oxygen uptake by the cells as a way of measuring what's active, right? The cells that are using energy are going to suck up oxygen, so you can use that as a measure of brain activity. And so, these babies were showing that they had activity in the areas we'd associate with memory when they were shown pictures they'd seen before. And so it was showing us that we seem to be forming memories as babies, but when we see a tree now or we see a rubber duck now, we know we've seen one before. We know even as kids we've seen that before, even though we don't have the specific memory of the first time we saw a tree or a rubber duck, right? You can't remember the specific time. You know you saw one. You know you saw one when you were a baby. A new paper has stepped that back even further with even more MRI machined babies.
Yeah, get those babies in there. Check them out.
Make it good. We did a new sting.
Yes. More babies in the MRI.
Yeah, please tell me they at least put 2 babies in one MRI machine.
Yes.
So they were strapping babies in, it was one at a time, in MRI machines to see how old we are before our brains can even tell the difference between something like a tree and a rubber duck. So let's put the memory bit aside. When are we able to even recognize the difference between objects like that? Do you have a guess?
Far apart too.
Like when do you think a human is able to actually look and process and tell the difference or categorize differences in a rubber duck and a tree?
Okay, let's think about this evolutionarily. When would you need to? Because the first few months of your life, all you need to be able to recognize is mum, nipple. That's basically it. That's your job. That's your life. That's everything. After
visual recognition.
Yeah, visual recognition. I know. That's what I'm thinking. You would only need those 2 realistically, and even that's shade. Like you could be not 100% on that. So when would you be? Maybe by the time they start crawling. When do babies start being independently mobile?
What is that?
I mean, it depends, but a few months probably. Yeah.
That's sort of my guess.
4 months, 5
I think
months,
it's
6
when
months.
they would be put down.
Right.
What is that? Like between 9 to
and up to 9,
14 months?
Yeah.
Maybe?
At that point in time, that's my guess. Because that's generally when you think about how children, I was going to say evolve, I mean develop. When they develop, it's usually to do with times of like there's a thing about how their eyesight develops in line with how far away they see their parents. Is like at the first part of their life, they can only see from like the end of your arm to your mum's eyes. That sort of stuff.
Shall we ask the only parent?
The only parent in the room?
Only parent, yeah, good, great.
6 months, you said?
Yeah, 6 months. The old adage, I think, is walk by 1, talk by 2. So yeah,
that's it.
Nice.
Yeah. So we're reckoning around 6 months, or if not older, for when a baby can tell the difference between a tree and a rubber duck. So this was published in Nature Neuroscience out of the Trinity College in Trinity College Dublin. QS ranking.
In Dublin, not London.
110.
28.
300.
75.
Oh,
underestimating Dublin.
Well, I didn't. I overestimated.
That was
a bit close.
They had 130 two-month-old infants. That's how young they went.
They raid a hospital or something.
That's a lot to fit in one MRI machine, which is why they did them one at a time. To quote the research, they were lying on a comfy beanbag and wearing sound cancelling headphones because MRI machines are loud. They're spinning heavy machinery and magnets around you at high speeds. The babies were shown bright, colourful images which kept them engaged for 15 to 20 minutes. They say this is the largest study ever done on awake infants in functional MRI machines where they had multiple observations over time, not just single images or something.
That's
So
sick.
this is a big study on very young infants.
Yeah, I don't want to even think about the ethics panel on this. Crazy.
They
Take forever.
well, all the footage they put out, they're very happy babies.
That's great.
They because they had that length of time, 15 to 20 minutes, and lots of images, they were able to show them pictures representing 12 common categories, including cats, crabs, birds, squirrels, rubber ducks, dishware, fences, food, supermarket shelves, shopping carts, towels, and trees.
Sorry, I love that crabs were in
Crab.
Crab. Everyone loves crabs. Go. Show them a crab.
And so they were shown multiple images that show those objects in sort of different orientations and slightly different variations. And so they were able to see and then looked at the brain activity going on at that time and go, are there any patterns here? Are these 2 months old telling the difference between these different objects? And what they say is looking specifically at these visual parts of the brain, which includes the primary visual cortex. So we're looking
Back
sort
of
of
the brain.
back of the
head.
brain, right around to where you sort of tuck your hair behind your ears. That bit that you're touching there, that path there, and they're specifically looking at the pathway that sort of runs along horizontally there at the back of your brain. They found that although, like you said, Max, not much going on in an infant of 2 months old, they're not walking, they're not talking, the communication is limited, but they found there were broad patterns within each of these 12 objects showing that the babies were able to categorize them in some way. There was similar brain activity happening when they saw pictures of cats or pictures of birds or pictures of trees or pictures of shopping carts. There was some sort of categorization going on here. They compared it to slightly older infants as well as to adults, and it was nowhere near as developed as you see it in an adult's brain activity.
I really hope so.
But there were clear categorizations things going on here. And they also found there were broad similarities. There was overlap. We're talking Venn diagrams here, but there were broad, you could draw circles around all of the animate objects. So the birds, the cats, the crabs, the life, the small inanimate objects like dishware, and large inanimate
And
objects
shopping
like
shelves.
shopping carts and shopping shelves and that sort of stuff.
So things I can grab, things I might be able to eat, things I can't grab or eat.
Well, who knows? But they had living, unliving, and in the unliving things, or inanimate, because trees are classified in that because they don't, they're not animated.
Right, I see.
They had small and large, so pretty amazing. And they say it shows that this sort of categorization in the human brain is going on a lot earlier than we'd previously thought. 2 months is a very young age to be doing that sort of visual categorization.
I guess you got to build up a database.
And shows that humans, on the database build-up in particular, they said this was really interesting for comparing, because they use AI models to look at the brain activities to help pick up on the patterns in the brain. But they were also then looking at the differences in how humans learn compared to these AI models learn. And they go, the human is able at 2 months of age, off such a small amount of information, to categorize a cat, a tree, a shopping cart, and all of these other things they were looking at, and everything else that they weren't testing that a baby's probably able to categorize to some level at least 2 months old. And then compare that to how much information gets fed into an AI model to achieve the same level of categorization. They said shows just how different the learning is in a human brain versus something like an AI model. And they say it could be really interesting to look at this sort of stuff and see, are there improvements we could make in how AI models learn by looking at how the human brain learns with such a smaller amount of information, able to reach such incredible heights, like at 2 months of age, being able to do these categorizations with a very, with the visual cortex and just using the information coming in through their eyes. And it could be really interesting to see how that could feed in, because, we have all these issues with how much information it takes to power these AI models and constantly feeding them more of that information, the copyright around it for artists in particular on their stuff getting pulled into these models. If you can train AI models, particularly ones that do good stuff like look at brain activity and help us understand our own brains, if you can train them on less information, that would be pretty amazing. And so the human brain development might be able to guide us in that direction. But pretty amazing stuff. A 2-month-old is able to categorize the difference between all of these different objects.
I'm going to show every 2-month-old I know cats now and crabs, and show them crabs and be like, this is a crab, learn what a crab is.
That's what I got for you, Max.
Part 3. Ethical lab testing attempts to follow the 3 R's. Do you know about this?
The 3
I've never had to do
R's.
an ethics thing because all of my work was done through satellites. Effective workaround.
First R stands for replacement, which is using non-animal methods wherever possible, such as computer models, cell cultures, or human tissues to achieve research goals. The second R is called reduction, employing strategies to obtain comparable information from fewer animals or getting more data from the same number, thereby minimizing overall animal use. And the third one, refinement, which means modifying procedures and husbandry to minimize pain, suffering, distress, or lasting harm to enhance the welfare of animals that must still be used.
It's the same as the 3 R's of just like work of risk management, right? That's like the standard stuff you avoid or like, it's
But
the same
yeah,
sort of
I mean,
idea.
that makes sense. I do think it's an interesting one because it almost goes, like, if you were going from a non-ethical perspective and just pure science, it kind of goes against what you're taught to do, which is that increase your data, increase your replicability, increase, like, just have as much data as possible no matter what. So I feel like you'd have this really interesting balance that you'd have to strike if you worked with animals to be like, okay, well, how can I make sure that the results are robust enough that I can actually draw a conclusion?
That's right. So then we can go to phase 1 trials of humans and so forth.
Yeah, exactly.
Anyway, currently rodents such as mice and rats make up most of the animals used in research. Other animals include fish and rabbits, along with some other ones which I will not mention here. Ideally, digital representations of ourselves, like digital twins, would be the most ethical. For example, you want to test a new drug formula on a particular, say, lung tumour. You could spool up a digital twin of some human lungs that exhibit the tumour, then input the chemical formula of the new drug to see how it performs, and that would be job done. But that's the future, and for now, how do we minimise the number of animals used in laboratory testing?
Is that an actual question for us to solve?
Yeah, well...
All right, team, let's dig in.
Let's do it.
I'll give you a word, though. Okay. Would you be what's your ethics when it comes to using insects instead of mammals?
I'm chill.
We've talked about this previously about how the ethics board sort of washes its hands of the insects and goes, you know what, do what you want. We've talked about UQ research about strapping backpacks to them and making them run around like little robots.
That did cross a line for me personally.
With electrical stimulation.
Just playing with them was a bit weird.
Yeah, that one was a bit much. But it had really cool outcomes, and I think it was probably in the end very much worth what they did. But it just felt a little much.
Yeah.
It felt like there was a line in my head where I was like, oh, that's interesting.
Might need to get Eco Radio in here to have a chat about that one.
So researchers at the University of Exeter, QS ranking.
Oh, gosh.
Oh, my gosh.
Exeter's high, right?
I'm doing
26 or
Exeter.
something?
What
do you got?
Hang on. No, it's in my head. 140?
Yeah.
No, that's wrong.
Close.
Anyway.
Yeah, close.
144?
155. Yeah. They developed fluorescent transgenic gene-edited greater wax moths that glow in a controlled way to indicate infection or response to treatments.
Hospitals would love that. Imagine if a patient came in and they're just glowing brighter. Triage would be so much easier. You're like, no, sorry, you can't come in. That guy's like a light bulb right now. Get him in.
All those situations where you have to inject the dye in to get, instead you just glow.
Yeah. Anyway, they reckon these moths act as sensors for real-time monitoring of diseases, allowing researchers to study responses to bacteria or fungi without needing mice or rats. Wax moths can be reared at 37 degrees C, which is the normal human body temperature, and their cellular response to infection closely mirrors that of mammals. They offer a rapid, scalable, and ethical, this is what they're saying, ethical alternative for early-stage infection studies. The engineered larvae can identify pathogens such as Staphylococcus and Candida, providing a live, visual, real-time window into disease processes and antimicrobial efficacy. One of the researchers, Dr. James Pearce, comments, our methods make wax moths genetically tractable for the first time. The ability to insert, delete, or modify genes opens up huge potential for understanding innate immunity to developing real-time biosensors for infections. And the paper is called Piggyback-Mediated Transgenesis and CRISPR/Cas9 knockout in the greater wax moth.
Wow.
Published in Nature Lab Animal.
Oh, they CRISPR'd them.
They did. They did. They gene edited them. That is fascinating, Max. Glowing insect larvae for diagnostics. It's
We could
crazy.
put them out into the world, and then if you go somewhere and all the insects are glowing, then you know it's like not
There's some
safe to be in.
pathogens there, yeah, totally.
That's kind of cool.
Okay.
Very Last of Us.
Let's go.
Do you know what tuna is?
Fish.
It's fish!
Thank God someone's working on this. I don't know what I'd do without it.
Fish are friends, not food.
Great start. Gabe, what does a cat say?
Yeah.
Max, what does a chicken say?
Cluck, cluck.
And Izzy, what does a shark say?
Okay, so I learnt a new word yesterday. I was very excited about this. Egested. Does anyone know what egested means?
Egested.
It's when you throw up, is
Egested.
it? Or?
That's 100% correct, Max.
Yeah.
So there's ingest, there's digest, and if you don't digest, you may egest. Just right back out the way it came. But we're very thankful for egestion. Taught us more about our oceans. Let's go back to the start. In late 2018, researchers from University of Exeter
155.
154.
It's correct, it's 155. They're coming at us, University of Exeter.
Aren't they?
They captured an Atlantic bluefin tuna measuring 175 centimetres and about 81 kilograms off of Cornwall in the southwest of England. That's a huge fish. Just to give you that fish is it taller than you? It's definitely taller than me. That fish
How
is
long?
taller than me, 175 centimetres.
Oh, Max and I are 3 foot tall, so
It's definitely taller than Gabe and Max. It's taller than me and heavier than me, which is crazy. That is just a huge fish, big fish. And the tuna was given a fancy little tagger that tracked depth, temperature, triaxial acceleration. So that means not just how fast it was going, but how fast and the direction of that movement. So you can kind of tell if it's turning over or flipping or whatever.
Okay.
And light levels, which is really interesting. So they could see if it was like really bright or really dark. The tagger was designed to fall off after a year, or if the tuna stayed at the same depth for 3 days, which basically just means it had passed away. Then it would float up to the surface, and they could go find it. Then the tuna was released back into the ocean. Now, the researchers are capturing and tagging tuna like this in an attempt to understand that there's a bit of a recent increase in tuna in that region, bluefin tuna. As you probably know, southern bluefin tuna are critically endangered. These ones are also endangered, so it's really interesting to see a rise in population. They're trying to have a look at it. The tuna then went on quite a journey, all the way down to the Mediterranean before returning to England. And that journey took about 289 days and was over 16,000 kilometres. Pretty impressive for a fish. You couldn't swim that far. You're not really built for it anyway, but still kind of interesting. You cannot. So I thought that was pretty impressive. But everything changed on the 7th of August, 2019. This tuna made repeated trips from the surface to about 100 metres depth. Then there was a sudden burst of activity as the tuna rushed to 126 metres depth, and the acceleration of the tuna at this point increased to 150% of its speeds thus far. So of the 289 days they'd been looking at it, this was 50% faster than they'd seen. So that's crazy. It then stayed down at that level for about 3 minutes before surging to the surface even faster, 4 times faster than that. So this is breakneck speeds for this tuna. And the tag recorded erratic and highly fluctuating changes in its pitch and roll as this tuna swam to the surface, meaning essentially it was flipping around, it was going back and forth, everything was getting a bit weird. And then it measured 2 prolonged periods where the tag seemed to be completely upside down, and the first time it was upside down, for over a minute, it was held above the surface.
Oh.
And then 19.2 minutes after the initial burst in activity, the temperature abruptly increased from 18.4 degrees to 32.4 degrees within 20 seconds, and everything went dark. So what do we think happened?
Long line.
You can text in with a guess on 0420 626 733 if you want to have a guess about what happened to this tuna. But I'm going to throw to the team.
Max said long line. It does sound like fishing, doesn't it?
Yeah.
But not the sort of fishing off a boat, because it wouldn't be that. You can't reel in a tuna faster than a tuna can swim.
Not. The tuna are very, very, very fast. Anyone who's fished for tuna will know just how fast they are, how muscular they are.
Commercial fishing could be it, but that's wicked quick.
So the commercial fishing came up, is one of the answers, but A, it's wicked quick, B, it's deep. Longliners aren't sitting at the surface, but they're not sitting at 100 meters below the surface either. That's quite deep for what they're trying to do.
Then there's only one answer, isn't there, Max? Megalodon.
I was just thinking that.
Singular. We've gone over this. If we're going to talk about Megalodon, you have to say plural because it wouldn't be one. That doesn't make any sense.
Megalodon.
Anyway,
Singular.
It is not a megalodon or megalodons, plural. The key here is the increase in temperature, the 32 degrees and the darkness, and a couple of other things. It got eaten, or at least the tag did, but, theoretically, we're pretty sure that tuna also got eaten because you wouldn't just eat a tag. But this presented a fantastic opportunity, the chance to track its predator, because yes, it was still tracking things inside the gut of the animals that ate it and transmitting data. So that's incredible. So what ate it? Well, large bluefins like this don't actually have that many predators. They're pretty close to the top of the food chain themselves. They are massive. They're wicked fast. They eat a lot of other things. But the tracker showed that the predator used surface-orientated diving. So once they started tracking it internally, they noticed that their dives started at the surface, went down and came back up, and its internal temperatures were about 35.9 degrees-ish.
Which means it's breathing air, and that's the mammal's temperature range.
That is a warm-blooded mammal, and it's breathing air. So it suggests a marine mammal rather than a white shark, which could be another predator. We're thinking marine mammal. We're thinking warm. Then there was a couple of options. There were 3 different options of marine mammals that are known to eat bluefin tuna. The researchers concluded the most likely answer is an orca. There were a couple of reasons for this, but I'm just going to move on in the fact that it's pretty much an orca. They were keen on that. And the tag stayed in the orca for 11 days, which, yes, before you ask, is quite a bit longer than their known digestion period. The most estimates of their digestion period is 58 hours.
Right.
Just a couple of
days.
Got
stuck.
Got stuck, yeah. Got stuck
cool.
in the gut.
Or it just really liked having it there.
Just decided to keep a tag. But during that time, we were able to learn a lot about the orca. So when the temperature sharply dropped, it was as they're eating and feeding small amounts of seawater into their gut, and so it decreases the temperature of the gut, and the tag got that. And then a small increase in temperature as digestion occurs, because the chemical reaction of digestion increases your body temperature. Yeah. And in the 11-day period from that data, they were able to record 77 feeding events. So this averaged out to about 7 meals a day. And they were able to say when they occurred, because it also tracks that, and it tracks all sorts of things. So they actually this orca ate mostly in the morning, between 7 a.m. and 11 a.m. That was its favourite time to feed.
Yeah, right.
They ate mainly at the surface, even when they predated at depth, because they could see from the way it was moving when it was predating something just before it ate. And so if it was predating at depth, it would chase something, grab something, it would bring it up to the surface to eat it, which is kind of cool, or close to the surface within 21 metres. They also found that they ate during the night as well, which was something that they're not entirely sure about with orca populations around the world, is how many night feed. This one seemed to feed sort of throughout the day in regular intervals, although as we've discussed, it prefers breakfast, this one. So all of this was so fascinating that in May of 2023, the researchers went back out and they tagged an orca in the Straits of Gibraltar, which is that bit of water between Spain and Morocco. And the idea was that they could compare the data and check whether the original predator was in fact an orca, double check their findings.
Sure.
And this tag was even fancier than the tunas, because it also recorded video. That's really exciting. Unfortunately, boom, 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 it fell off after only 30 minutes of footage. Yeah. But in that time, they did get some data. Literally within 2 minutes of the tag being deployed, the camera showed fragments of fish floating past, an ominous foreshadowing for what we see next. The orca that we're attached to dives, and then you see an Atlantic bluefin tuna dead, having been killed by an orca that we see swimming after it. So from the depths, a bluefin tuna followed by an orca within 2 minutes of this tag being deployed. So in the obvious fail of 30 minutes of footage, not what they were wanting, they had managed to capture the exact thing they were looking for, which was orcas coming together to hunt bluefin tuna. So the third orca comes and rips out the abdomen of this tuna. So the second orca is holding it, a third orca comes in, rips out the abdomen, and it gets messy, but they eat the fish. They together eat the whole fish except for a bit of the head, which, fair, doesn't look like a great bit to eat. And while the tagged orca did not record them actually capturing the bluefin tuna, it shows the cooperative feeding between the orcas, the handling of the prey to facilitate the tearing of the meat from the fish, and it correlates almost exactly with that prolonged period of handling before the ingestion of our original tuna. Remember when it was rolling around and being held in the air? It's pretty much the same thing. It's just being manipulated by the orca to be fed upon. It also... orca are known to sort of play with their food before it's dead.
They're bullies.
So they're a bit intense about that. So that they think could also be why they held it upside down in the air for a minute, because it would stress the fish out. And we never would have known any of this about the orcas' feeding times, about how they dive, about how they cooperatively feed on bluefin, if that original orca hadn't looked at that original tuna and decided that's its time. It's gone now. Isn't that sick?
It is great.
Pretty good.
Yeah.
I love the idea that just maybe, it's almost certainly not what happened, but just maybe the same orcas that had this orca had this thing stuck in its gullet for 7 days and finally got rid of it, and then it or one of its mates ends up with a similar looking thing stuck to it with a video camera, and 30 minutes later they go, enough of this crap.
We don't want to be watched. Big brother over here, honestly.
What do you got, Max?
I'm trying to queue up a song.
Okay, it's time for the best part of the show. Loosely defined as science, yeah, you already know. Everybody listens to 4ZZZ just to hear us talking about what Butters just did. Subscriptions just keep rolling like the tires on a car. But something tells me that our science curves won't go far. But unlike an engine, I won't keep you in suspension. We're all here to hear him talk, so let's give him attention. You're not ready for when he starts rapping. Gonna hand the mic to Max, and I'm not talking Van Stappen.
F1, the season's heating up now. Pre-season testing is upon us. All the liveries have been dropped for the 2026 cars. Anyone want to discuss the liveries?
The Cadillac one is really interesting because it's asymmetric. I can't remember the last time we saw a team that actually had an asymmetric livery.
Yes.
I think it was a team that wanted to run two different liveries and they couldn't, so they sort of literally split them down the middle. But this is a little bit more deliberate, I think.
Yeah. I mean, the FIA stipulates that both team cars have to have the same livery, but they can still have an asymmetric look to them.
Yes, I was going to say, it of course it was British American Racing, because they also did the World Car and they had all the crazy liveries. But yeah, in 99, BAR ran an asymmetric.
And it's a good look. Audi one, I like. It's got a bit of an R8, their supercar feel about it, with the lava red on the sides. So
is that actually what that's called?
Lava red, yeah. The colour.
That's crazy.
Lava red.
Yeah. That's what we said, wasn't it? Last week or 2 weeks ago?
Maybe.
Yeah.
For what, Audi? Yeah.
Yeah, I think so. Anyway.
Yeah.
Gabe?
It's a good looking red, by the way.
Yeah. Gabe, you got any thoughts of the liveries?
They look the same as last year, except for the teams that are brand new.
You got to give a little bit of credit to Red Bull.
Yeah, Red Bull's blue is fantastic. And look,
it's just as impossible for a new fan to try and figure out who is in which car.
I'm not vibing the Ferrari this year with that white sort of around the cockpit area. I don't think that works necessarily, but that's just me, personal taste. Anyway, pre-season testing will happen today in Bahrain. You said they're already on the track, Maxi, or?
Yeah, they're all on the ground. I guess because it starts today.
Yeah.
Not sure what time that is, but
6 p.m. our time is when the kickoff for day one is.
Right.
6 p.m.
Or 5 or 6, something around then. Yeah.
Cool.
Awesome.
Because they got 2 sets of pre-season testing before they make their way to Melbourne in 26 days. The race is going to happen.
Gosh.
So it's less than a month away. So we'll be down there reporting about the event, and hopefully we'll talk about it in the following Wednesday show. And I'm saying RIP to Aston Martin's safety car.
Oh, really?
Yeah.
This is true, yeah.
Yeah, Mercedes are the exclusive sole provider of safety cars for 2026. Clearly, they spent a lot of money on getting Adrian Newey on. They can't afford the safety cars this year. That's just conjecture. Yeah.
Yeah.
What else? Okay. Any more to add about Formula One? I guess we'll talk about it more next week because after the pre-season testing.
We'll have something more to go on.
Yeah.
3 more days of testing to come.
There is some racing this weekend. I think we've got the Bathurst 12-hour, which is happening in Bathurst, clearly. It's just a GT race with professionals and amateurs getting around for 12 hours, would you believe? And this is from their website. They say the race has firmly established itself as one of the world's premier GT endurance events. The 12-hour delivers non-stop action for 12 hours of high-stakes racing, international stars, local supercar heroes, and some of the most exotic machinery on the planet. So
Good stuff.
You get to see Porsches, Mercedes, McLaren, Aston Martin, all the rest. And there's also Daytona 500 this weekend as well.
And the Sail GP.
Oh, is it?
In Auckland.
Ah.
Sick.
Is the New Zealand boat ready to fly or not?
I believe so. I haven't seen anything to suggest it's not. But, yeah, it'll be interesting to see. The British boat's going to be hard to beat on the basis of the latest race over in WA.
Yeah, which you got to witness. Is there anything from the F1 Academy?
Yeah, exciting news. Dorian Pan will be contesting in the 2026 European Le Mans Series, joining the De Queen team. She previously competed in the series in 2022, securing 1 win and 1 podium with Iron Linux. It'll be kicking off. She's doing 4 hours of Barcelona on April 12th, and the 6-round season will also finish, obviously, Imola, Spa, and Silverstone before finishing in Portimao. We've also got our first signing for the 2026 team of Mercedes with Peyton Westcott, who has been locked in. She took part with the F1 Academy Discover Your Drive series, and she was a champion of that Future Academy program. She started racing when she was 6 years old, and is very excited to be joining the Mercedes family for the 2026 F1 season. Finally, we also have our wild card secured for Shanghai with Chinese driver Shi Hua, also known as Tai Dao, returning as the first F1 wild card. Essentially, in F1 Academy, they have wild card entries where they take female talent from every single host city and put them in with the F1 Academy drivers to kind of show off, earn some points, and get themselves starting up on a leadership or leaderboard for F1 Academy. So that'll be very exciting. Unfortunately, we won't see the girls in Melbourne, but we will be seeing them in China.
There you go. So I have to go there.
Yes.
Any more for the MotoRap this week?
Nah.
I think it's a wrap.
What do you got for us, Issy?
I am trying to find the QS ranking of something. Sorry. All right.
Critically important.
Exactly.
What are you doing?
Wake up!
I started that. Sorry.
Wake up, everyone! The Bin Chicken family is expanding with a new member found in Hawaii. Researchers from the University of Lethbridge in Canada and Flinders University in Australia. I'm going to give you 2 numbers. You're going to guess which one is which.
Okay.
387.
That's Flinders.
That's Flinders.
1,501.
That's got to be the
Canada.
other one.
They found
Why are Canadians interested in bin chickens? I get Flinders, but Canadians?
I think it's because it's got a little bit of archaeology related to it.
Maybe they just wanted to go to Hawaii.
Yes.
Sometimes this stuff is just like the researcher just was
Yeah.
used to work with them, and then they moved to Canada, and they still work together.
There is, I think there's an Aussie researcher who was from Flinders University. This is just me talking, who's then moved to Canada, because there's a pretty good quote from them in here. Anyway.
You talking is the entire format.
That is the plan.
They found a distant cousin of our beloved bin chickens in Hawaii. These researchers found this connection when examining the skull of Apteribis, an extinct flightless ibis that once inhabited the Hawaiian island, specifically Maui Island. They used museum specimens internationally, examining skulls from 25 of the 28 living ibis species, and used imaging technology to create 3D reconstructions of the bird's brains and compared them with the fossil species. Pretty cool. They then found something pretty interesting about this new species that they found. They found that all parts of the bird's visual system, like the eyes, the optic nerve, and the optic tentrum area where the light is processed by the brain, was much smaller than its living relatives.
Oh,
so
couldn't see very well.
I couldn't see very well, and
Pity,
obviously
since it lived in Hawaii, that would be a nice place to see.
Well, these they immediately went, all right, where have we seen this before? These extreme reductions are known in a few birds, including our Aussie night parrots and
I'm going to guess a lot of kiwi birds, including the kiwi.
Kiwis.
A lot of our birds don't have great vision.
Nighttime ibis.
What do these birds have in common? They are active mainly at night. Ding, ding, ding. That also makes sense. Looking at the Hawaiian Islands were once home to a diverse number of snails and flightless crickets that were nocturnal. and may have changed the bird's hunting patterns to primarily nighttime hunting. Additionally, birds like the ibis don't need accurate vision because they don't fly. So, especially on Hawaiian Islands where there wasn't a large native mammal predator prior to obviously humans coming in, they wouldn't necessarily need to have super accurate vision in order to fly away or to migrate. So it makes sense why the optical nerves, their eyes, were much smaller. Unfortunately, of course, we are looking at fossils, therefore they are extinct.
Yeah, they now fly.
Yep, so possible causes of extinction were discussed include changes to the climate, obviously, and vegetation, and, of course, humans.
Yeah.
I really like this quote from Professor Andrew N. Iwaski, who said that the New Zealand kiwi was often seen as a one-of-a-kind oddity amongst modern birds, but this extinct ibis shows that similar forms evolved elsewhere. So now we're seeing some really unique kind of, it's really cool. They spoke a lot in this paper about how islands cause animals to evolve in kind of weird and funky ways. See the kiwi, see Australia, see now this bird. So it's really cool seeing these kinds of, drawing these connections from other areas that have these weird kind of funky birds, and seeing, why did they evolve in this certain way? So seeing these nocturnal hunting patterns come through. So welcome to the family, the Abbotsford ibis.
I mean, I think this is great because for years people have always talked about kiwi as if they don't know, oh man, it's a mistake, what a silly bird, oh my goodness, look at that thing, so broken. And it's no, it's actually evolved perfectly for what it was meant to be doing.
Fit for purpose, yeah.
Fit for
purpose. Like a lot of our birds. Yeah, they might not be like your birds, but they did what they're meant to do. Damn.
Yeah, the lead author of this paper, Sarah Cretan, said Abbotsford ibis was a relative of the Aussie white ibis, commonly known as the bin chicken for their habit of rifling through rubbish bins with their beak. But really, ibises are beautiful and distinct birds, with exceptionally long, elegant beaks and striking colours that set them apart from shorebirds.
So elegant's not a word I'd use with a bin chicken, but I respect the hustle.
Yes. So very exciting. And there's some really cool illustrations that they've done up about this they've roasted him, nearly blind Hawaiian ibis, they've called it. So, expanding the family.
Cool.
Hit it! Hit it! Hurry up!
Yeah.
You tune into 4ZZZ, and the show is No Idea with me, Max. We've got Issy, we've got Peta. Gabe, we've been...
text line's been popping off.
Yes.
We've not been given it our dues, and Marky called us out for why, because it's been all over the shop, and Marky texted in saying, this is great, everyone seems tense. It's okay, I'm tense too, I ate tuna.
Thanks,
and then later texted back in when Peter was doing the mystery of what happened to the tuna that was being tracked. Yeah. Marky texted in saying, I ate it for Smoko. And then Muzz texted in saying, I think a submarine scared a whale that flipped a shark who got scared and thought it needed to eat more and grow larger. And then there's been all sorts of other texts coming through as well. Stacey not buying that AI models can do good stuff when we were talking about the models that can use that they were using to monitor babies' brainwaves, just to try and understand the development of our brains at 2 months of age and what we can categorize. I think it's fair. I think we would all agree that's good stuff for an AI model to do, right?
Yeah, there's bad stuff and there's good stuff. Like counting salmon, really good. I don't want to be doing that.
Running through 15 to 20 minutes from 130 babies' brain scans is not just a tedious task for humans, but also we wouldn't be able to pick up on some of the patterns that an AI model could.
Actually helpful for people's health.
Does good stuff, but also a lot of bad stuff. We'll give you that. And what else did we get texted in? Kate texted in saying just eliminate the cosmetics industry, Max, to get rid of all of your issues with animal testing.
Yeah, 100%.
And CJ texted in saying equal parts fascinating and horrifying as always, team. Those poor insects. About your glowing moth larvae, Max, picking up on antibiotics.
And upset.
And Pete texted in, g'day legends, on the new F1 liveries, the colours of the new F1 cars, their new paint jobs. I thought it would have been a nice touch to put a little alfoil hat over the halo on Aussie's Oscar Piastri's car to reflect the attitude of most of his fans who think he'll win this year.
That's it.
Let us be
Pretty brutal, Pete.
Conspiracy
Let us
theories.
dream. If you want to jump in on the convo, we get everyone's all those names because those people have subscribed to 4ZZZ. And when you text through on the number that you subscribed in, we get to see who you are, and it's nice. We get to see who's texting in and check in every now and then and
Muzz text
see what's going on. If you want to join them, 4ZZZ.org.au/support is the website. The subscribers we get do literally keep us on air. Max, what are the prices?
If you're under 18, it's $25. If you have a pet, subscribe them for $25. Concession, $40. A full subscription is $80 a year. Passionate subscriber, $140. You get a T-shirt. Super sub, $500. You get a special T-shirt. You get your name written downstairs. Anything? Well, there's a special
we got a sub prize. It's February with White Lies and Yeasty Boys Pizza chucking in some. Every time you subscribe this month, you'll enter the draw to win 3 mixed cases of White Lies beer and a $50 Yeasty Boys pizza voucher available for only the 18+ subscribers. Sorry, every pets and children. But yes, you'll go into the running every month with a new sub outlet who's helping spread that warm inner glow.
Good stuff. Now, I want to play you a little clip here.
Of the Backstreet Boys?
Well, we'll get to that. We'll get to that. I want to play you a clip. I want you to try and keep the beat with this song. A little hard, yeah?
Yeah.
A little difficult. What we're listening to there is a scrambled song that's deliberately made so you can't keep a beat.
My brain.
The real clip used in the study for, both were used in the study, but the one used to try and see what can keep a beat was this one. And that was used on 2 male macaque monkeys because across the entire kingdom of life on Earth, the only species we've proved can keep up, for a long time we'd proven that could keep up with a beat, were humans and certain birds like sulphur-crested cockatoos and palm cockatoos. I don't know, we actually covered, I don't know if you remember, we covered the story of the palm cockatoos keeping a beat by knocking sticks and seed pods against the tree they're nesting on.
And who else?
Do you want to hear this? We'll get to that, Peter.
Thank you.
I've got the story, I think. Here you go. Here's the sticks of the palm cockatoos. They're able to keep a beat, and it differs across the birds. But then, so people for a long time have been thinking, well, maybe being able to keep a beat and sort of, thinking about how music evolves, maybe keeping a beat's about vocalization. We have such different brain anatomies and physical anatomies to a bird, but humans and birds both rely heavily, particularly the parrots, rely heavily on vocal communication. So perhaps beat keeping comes after intense vocalization, right? If you communicate in complex vocalizations, maybe
then you should be able to rap.
You get some sort of beat coming from that as well. Maybe, should be able to keep a beat, maybe not rap. But then some interesting stuff has happened. We talked about this on the show. You talked about this on the show,
I
Peter.
was ready to fight you if you didn't bring
sea
this
lion
up.
called Ronan came along, who was able to keep a beat as well.
Very, very accurately.
Yeah. A very well-trained sea lion who doesn't represent all seals and sea lions necessarily.
But she did it on her own accord. That's important. It wasn't just when she was asked to do it. She did it just for fun too.
So it kind of kicked this idea back to the drawing board of why we can keep a beat. Where did this come from? It's maybe not vocalization. Seals aren't particularly vocal creatures for their communication. So they were like, okay, let's try and scale this back a bit. So they went and picked up an interesting subject for this research: macaques. So it's a primate type of monkey.
They're pretty close. They should be able to.
Similar physical structure and brain structure to humans, unlike birds that have been tested quite a lot for this sort of stuff, but they aren't particularly vocal. So the macaques don't have this heavy vocalization that we would, or that some of our closer ancestors would, but they still have the other similarities. It's a good test of, let's see, in a similar species to us that isn't heavily vocal, can they keep a beat? And so this was published in the journal Science and came out of the National Autonomous University of Mexico. Can I get a QS ranking?
Well, it's good they're autonomous. 87?
440.
600.
100. 136.
Oh.
And they did have a little help from the Backstreet Boys in this research that I'll get into. So what they did, they had these two adult male macaques that had previously already been trained to keep time with a metronome. So they'd been using rewards. They'd been able to train these macaques to keep in time with a metronome, which isn't beat keeping.
Technically beat keeping,
it's sort of
beat
just
keeping.
yeah, exactly. It's doing the beat keeping for them, and they're doing that. But they'd been trained to keep time with a metronome. They then played them one of 3 human selected songs, like the one you heard before, and this one here. I think this is a New England. Nope, that's something else entirely. I'm in the wrong sound.
He's just playing us random animal sounds now.
I'm not looking for a New England.
That's the other one, a New England, Kirsty McCall. The other one I played to you was You're the First, You're the First, the Last, My Everything by Barry White. And then there was another one, a classical song they also played as well. And so they had these 3 songs, and they effectively were like, okay, can they keep a beat with these songs? So they'd play a bit of it, and what they were looking for was for the monkeys to make, I can't play you a sound that they were making because they were just gesturing with their hands.
Okay, cool, like a conductor.
The monkeys, so just sort of pulsing their hand back and forth in time with the beat. And so they'd set up in the little weird experimental spot they've got. They'd sit there, they'd put their hand through a thing, and they'd start playing the music, and they'd just go, can you push your hand back and forth in time with this music? And what they found, and they were looking for at least 5 taps or pulses with the hand within 20% either side of the beat.
Oh, man. I
And they
wouldn't
played it
accept
at slow and fast tempos as well. They found that with the rewards, if they rewarded them when they got it right, they were able to do it correctly. Most of the time, they would get the right beat.
Okay.
Sometimes it would take them a minute. They tried to test songs that had more and less obvious beats because it's somewhat subjective, like based on human musical culture where you place the beat and certain stuff, and some of the sort of excerpts they use were a little ambiguous deliberately to be a bit more difficult. But they found that they were able to do this. These 2 male macaques were able to find the beat, so they would pulse their hand at the right tempo. On the right beats. And so that was pretty amazing. That was the first part of the study. They found they were able to do it. Then to test them a little further, because like you said, Peter, there's other stuff going on there where they're like getting rewards and things. So they went, okay, let's do one last phase of this study where we play them the Backstreet Boys, everybody from the Backstreet Boys. And they all ran away. They weren't even chased. But they got a reward whether or not they got it right. So they were just saying if they at least participate in the study, they get a reward for this one.
Yeah, because
they have to be there and
Backstreet
actually
Boys.
doing something with their hand, regardless of if they got the beat right. And they found the 2 macaques got it right still. So they still found it. And even when they'd never heard the Backstreet Boys song before, that's why they used it.
What an exciting time in their lives.
Yeah, and they also played them sped up versions at 2 different tempos as well, and they got the same thing as well. Yeah, the TikTok versions.
Yeah.
And they got that as well. So they found is that these macaques are able to keep a beat, and they were also able to do so with stuff they hadn't heard before, and when they weren't directly receiving a reward for getting it right. They were just receiving a reward for participating in the study, which is pretty impressive because it does put more evidence behind this new hypothesis that being able to keep a beat probably doesn't come from vocalization. Obviously, it's still too early to tell conclusively, but doesn't seem to be tied to being heavily vocal, like humans are, like a lot of parrots are. What instead they propose is called the 4 C's hypothesis, which means any animal, potentially, that can detect patterns in audible patterns, auditory patterns, so detect sound patterns, can make predictions, so can predict how that sound pattern will go into the future, can coordinate their motor actions, the way they move based on that prediction, and can associate that behavior with a reward, could be able to display beat keeping. So
then why am I sitting at concerts hearing people not clap in time?
Because they're not getting a reward. They need little cups of juice and water like these monkeys got.
Petition for all venues to start doing that. I'm at the end of my rope.
So this is the hypothesis. Anything that can hear these sounds can make predictions through time, can coordinate their actions based on those predictions, and can get a reward associated with that behavior. Could be able to keep a beat, which then means the question now of this: where does beat keeping come from, and how does that feed into the evolution of music? Could be that it's not just about what can keep a beat; it's what does and what makes things actually keep a beat, because this is not natural behavior that these macaques were expressing. They were being enticed into this, and they were not in wild, they were in captive conditions. They were being enticed into doing it. So the next question now is, well, what actually triggers an animal to exhibit that behavior of beat keeping and other sort of musical?
I've always wanted to know
things?
why I dance. I have this thing where if there's a good song, I actually can't stop myself from moving.
Yeah.
It's just in my bones. And I've always wondered, why do we do this? People do it on their own. It's not necessarily a social thing. I'll dance around the house. It's just something humans do. We're just like, hell yeah, move my hips. This is a great song.
It would be really cool.
What is that?
To think about it like beat keeping in nature and why. And at least going to Laneway over the weekend where a few people would start clapping and then everyone else starts clapping to a song that is clapping, or someone would clap and everyone that, that shame immediately where it's like, oh, you're offbeat, where that comes into play in a natural environment.
I'm the one giving the shame. I give the eyes. I'm like, stop. If you can't do it, just stop. Just pretend.
Hey, Max, what do you got for us?
There's no need to back announce it. Let's do it. No idea. Space news. I'm going to talk about Luna 9. It's 1966, the USSR Luna 9 mission became the first human-made object to land safely on the moon's surface and to transmit photographs from another celestial body. Equipped with an inflatable shock absorbers, the capsule bounced around several times before settling down and putting out 4 panels to secure it. Although Luna 9 operated for just 3 days, it transmitted a wealth of valuable data back to Earth. Unfortunately,
it's more than that tag on that orca, so hey, I've been pretty good.
Unfortunately, its exact whereabouts remains unknown.
Oh, what? How?
Coordinates were published at the time, but further observations by satellites passing over the landing site have found no detail of the actual object. Now, this is where India's Chandrayaan-2 orbiter will be passing over the region in March, and a team of researchers have trained up some AI, sorry about that, to find out if the Luna 9 is actually within said area. So they're looking towards 10 kilometres either way of what the coordinates were related back in 1966. Perseverance is another AI thing, so if you want to turn the radio down, that's fine. Has just been sent its driving instructions from a generative AI model. The system examined high-resolution orbital images captured by HiRISE on board NASA's Mars Reconnaissance Orbiter, along with some terrain slope data from digital elevation models. And using this information, the AI identified important surface features such as bedrock, outcrops, boulder fields, and sand ripples. It then produced a continuous driving path that included all the necessary waypoints for Perseverance to follow. Before sending the commands to Mars, engineers ran it on the twin that they have here on Earth in JPL's laboratory. It went through the 500,000 telemetry variables to ensure the plan would work safely before uploading it to Perseverance's flight software. So Perseverance travelled using AI alone 210 metres, and then on another day it travelled 246 metres without any intervention from the JPL researchers.
I do love the idea that at the end of the 210 metres, someone at NASA headquarters like, no, that's a rock. That is in fact a rock. Abort, go left. Oh my God, go left.
And some more worrying science about space, the Kessler syndrome. You know, this is the cascading effect when one satellite hits another satellite, and the debris from that satellite hits another satellite, and so on and so forth until we have our own ring like Saturn, but we can't get back into space because there's no way to penetrate all the space debris up there. Well, there's a PhD student who's been working on that. It's called Sarah Teal. And she's worried that even though the satellites in low Earth orbit currently have their own manoeuvring capability and telecommunications with Earth, if they really need to change direction quickly, it is estimated that every 22 seconds there is a close encounter between satellites in low Earth orbit, where a close encounter is estimated at 1 kilometre apart or less. Now, Sarah's worried because if we have a solar storm, it could knock out the satellite's own navigation and telecommunication systems for several days. And she has hypothesized that the current number of satellites in low Earth orbit, it would only take 2.8 days, let's say 70 hours, before two satellites would collide.
Yeah, right.
This feels like something we should do something about. I feel like scientists in the 70s, when they discovered climate change, they were like, hey, this seems like maybe catastrophic. Like, we should probably act on this.
And that's it for the Space News. Gabe, sign us out.
That is all we have time for. This flea-free show is brought to you thanks to all of the subscribers at 4ZZZ. You can join them at 4ZZZ.org.au/support. That website is also where you can listen back to the full recording of this show with all the music as well as a bunch of our previous shows. The condensed version is available on your podcasting platform of choice. Just search No Idea 4ZZZ. That's No with a K. No Idea 4ZZZ. We're on socials as well at No Idea 4ZZZ. Pushing stuff out every which way. The seal's up on the socials as well. That sea line, rather, they can keep a beat. Thanks to Toby for editing up the pod. Thanks to you, Max, Issy, and Peta for your stories this week. We'll be back in your ears next week between now and then. If you're heading to Hawaii, look out for extinct night ibis. Maybe steer clear of glowing moth larvae. And if you're tracking tuna, don't get too attached. And be better at keeping a beat, because a monkey can do it.
Thanks for everyone texting in today. It made it for a great show. Yes, we were a bit tense, but it made it all better. And we'll speak to you next week.
See ya.
Bye.
I'm a goddamn marvel of modern science.